So, good day to you. This is Tamontok from Bachelor of Science in Agricultural and Biosystems Engineering. So, welcome back again to Fluid Mechanics, and this is a new chapter, Chapter 3. Problem came from the book Lasagna. So, from numbers 3-16. So, the problem is, determine the magnitude of the force on the inclined gate 1.5 meter by 0.5 meter shown in the figure 001. The tank of water is completely and the pressure gauge at the bottom of the tank reads 100,000 Newton per meter square. Use 100,000 Newton cubic meter for water. So now we will use the formula. F is equals to the specific weight times the height times the area. So now, these two is also equals to P minus the PCG. And now, what is this P? This P is the reading pressure at the bottom of the tank. So, the value is 100,000 Newton per meter square minus the PCG. So, what is this PCG? This PCG is the pressure center of gravity. So, now we don't know yet what is the value of that. So, we left that as PCG is equals to the specific weight. Our fluid here is water, and stated in the problem that the weight of the water is 10,000 Newton per cubic meter. So here we don't know what is the value of the height. So we have to solve for the height. So we know that here the plate looks like this. So here is our center of the gravity. So now we are looking for the height, which is here. This is the, we are looking for this height. So we know that here in the problem, in the figure, it is shown that this is 60 degrees. So here we know that the length of here from here is 1.5 meter, and here we know that it is 2 meter. So to get so we know that this is a right triangle. So we need this hypotenuse. So to get that, we need to divide 1.5 divided by 2 to get the hypotenuse. So now this is a right triangle. So there are a lot of ways to solve this, like so, ka, towa. So here we will use the so is equals to opposite over the hypotenuse. So here we know that sine theta is equals to sine 60 degrees. So sine 60 degrees is equals to the opposite over the hypotenuse. So here we know that the opposite is missing. So we left that as h since we are looking for the height. And here we know that the hypotenuse is equals to 1.5 over 2. So now that we get the value, so we simply transpose the h here. So we can get 1.5 over 2 times the sine 60 degrees. This is meter, this is meter. So now we can get the value of the height. So the value of the height is simply put it in calculator. We can solve it as 2.65 meter. So here we put 2.65 meter. So we can simply solve the PCG here. So PCG is equals to, move this 100,000 or the pressure at the bottom of the tank, 100,000 Newton per meter squared minus the product of these two. So the product of these two is put it into a calculator, the answer will be 26,500. So the unit for here is, we can see that we can cancel this 1 meter and we can cancel another meter here. So we are left with Newton per meter squared. So now we can solve for the ECG by subtracting it. So if you subtract that, we will get the answer of 73,500 Newton per meter squared. So we know here that the PCG is also equals to here. So we can simply, if we go back to the formula, which is F is equals to FH specific weight times the height times the area, we can also use this as the equivalent for these two. So we can input 73,500 Newton meter per square second times the area. So what is this? The area of this rectangle. So we know that the formula for that is length times width. So we can easily put as 1.5 meter times the 0.5 meter. So if you multiply this two, if you multiply this, we can get the answer of 55,125. So here we can see that we can cancel this meter. So we are left with a Newton. So that is our final answer for the problem.